If you keep getting area and geometry questions wrong, it's usually not the maths, it's the units and the setup. So if you convert, then choose, then calculate, then these become some of the easiest QR marks that you're going to come across. My name's Farhan, I'm a junior doctor, and I've helped over 100 students get into medicine and dentistry across Australia. And in this video, you're going to learn how to handle area and geometry questions through using conversions, applying formulas, and then applying these questions to real-world questions. So let's go through the 3C's of area and geometry. That is, convert, choose, and calculate. So conversion is all about changing the lengths into the same target unit. Choosing is knowing the right formulas to use, and then you start calculating for the answer. So let's go through each one of them. Starting off with convert. So the common trap here is mixing up the units. So my advice to you here is convert everything to the same desired unit before continuing. So for example, if all of your answers are in kilometers squared, then convert the lengths you have in the question to kilometers. It's going to make your life easier. Now, if you want a diagram on how to convert between kilometers, meters, centimeters, and millimeters, here it is. Just etch this into your brain. Now, what I want to do is tell you why we do this squared function when it comes to moving in between millimeters squared, centimeters squared, and so forth. Because a lot of us know this off by heart, but we don't know the concept behind it. So if you know the concept, it'll actually make some of the more harder questions easier because you know the foundations. So, for example, if we have something that is 100 millimeters here and then 150 millimeters here, and we know that the area is going to be 15000. So this is in millimeters squared. We want this to be in, say, centimeters squared. Then what are we going to do? We're going to divide by 10 squared. So that looks like moving the decimal place from here to here to here, 150. But instead of just knowing that through theory, what we can do is look at why that's happening. So the reason we do it squared is because we're working with 2 units here. So I'll show you what that means. If we're to convert this directly into centimeters, then that'll give us 10. If we're to convert this directly into centimeters, that'll give us 15. Now, when we multiply 15 by 10, what does that give us? It's going to give us the 150 we were looking for. So the reason why we do it twice, why we divide by 10 twice here, or 10 squared, is because we're working with 2 different units here. So I hope that makes sense because it'll make some of the harder questions we go on with later easier. So let's start off with an example here. Liz owns a plot of rectangular land measuring 70 meters by 85 meters. What's the area of this plot of land? So you've got these options in front of you. I want you to pause the video now and to have a go. So you've really got 2 options of going about this question. Number 1 is do what I just said and turn these into kilometers instead. The reason being is because you know all these answers are in kilometers, and so if you turn these into kilometers, then you'll just get to your answer directly, which is E. The other way is to multiply these first and then remember to divide by 1000 squared because we're going from meters squared to kilometers squared. No matter which one you choose to do, all you need to do is remember to convert. Just remember to convert. I don't care which one you choose to do, before or after. Some of you might find after faster, but the reason why I'm suggesting before is just so you don't forget. So this is the reason why convert is step number 1, because even if you do the conversion later after your calculation, I still need you to think about conversions at top of your mind. As soon as you go into an area question, you think about conversions because this is where so many people mess up. Like, they're not all that difficult. It's just the conversions and the stress of time that keeps us from getting the full marks that we know we can get. Okay, so that's what I want to say for conversions. Let's go into step number 2, which is choosing the right formulas. If you don't know these formulas, now you do. If you want to find the area of a square or a rectangle, it's length times width. For a triangle, it's half times the base times the height. For a circle, the area is pi r squared. And then if it's like a semicircle or maybe like a cutout of a circle, then it's the angle that we have here divided by 360 times pi r squared. If you want to find the circumference, then that's as simple as 2 pi r. And then we've got a trapezium, which is half times A plus B, so whatever that value is, A plus B, times the height. So now that you know these formulas, this is basically all you need to know going into the UCAT questions. If there's going to be a more complicated shape, then they'll just give you the formula to use. This is not a game of how many formulas you can memorize, apart from these, because I think these are expected to be known, but it is a game of how well you can apply. So then the next step from choosing is simply to calculate. So this is the 3C's of area and geometry. And now if you found this helpful and you want access to all of my frameworks in one place, then you can click the first link in the description below for exactly that. Otherwise, let's go through some worked examples, starting off with this one. I want you to pause the video here and have a go. So hopefully you've had a go at this question. Now, the first things we do is have a look at what's in front of us. The diagram below shows the perfect floor plan, and we've got C is a perfect square. Important piece of information. We've got the floor plan in front of us, we've got a conversion here, and then we've got some material and costs. Great. So now that I know what I'm looking at when I actually read the question, it's going to be easier. How much will it cost to install laminate flooring in room C? Now, so we have this height of room C, but we don't have the width, except we do because we know that C is a perfect square. Can't tell you the amount of times that people miss a piece of fine print like this just because they don't read what the question's telling them. So we have 5.3 times 5.3 times 12.8, giving you around about 359.42. Might not be entirely exact, but it's rounded. On the day, you're going to look for exact numbers, so don't do what I just did there. But for the sake of these examples and for the rest of this video, they might not be exact, so go with the closest number. All right, let's move on to our next question. What is the value of x? So pause the video here and try and figure this out if you can. All right, so let's run through this one together. Some of us might have found this a bit more difficult because now we're working with feet in this instance, but this is where those foundations that we just went through earlier in this video come in. So what's the value of x? We're looking at x here. So we know that we need to find the area of D to be able to work backwards and find this because we've got the height here. We need to find the width. So area equals length times width. And what we're trying to do here is find the length. So the way we do that is length is equal to area divided by width. So we have the area actually. It's 308.77 feet. Now the thing is, we can't mix up the units. We can't divide feet squared with these meters that we have. So what we want to do is have everything in the same unit. Now I can see that in my answer options that they're in meters. So I want to be working in meters so that as soon as I get my answer in the calculator, I know I can just pick whatever answer it's going to be. So with that said, how do we calculate the area of this in meters squared? This is where a lot of us might get confused. Now, what I want to illustrate to you is the thinking behind it. So if I instead change this from 1 meter is equal to 100 centimeters, this would become a lot easier, wouldn't it? Because you would have to divide by 100 times 2 if you wanted to go from centimeter squared to meter squared. So what changes here when it comes to feet? All that changes is the number here. So what we'll need to do to go from feet squared to meter squared is we divide by 3.28 twice. 3.28 squared. The reason being is because we're working with 2 units here, 2 lengths here. So that's the reason why we do it twice. And then so if we do that, we end up getting the number, let's put this into the calculator, 308.77 divided by 3.28 divided by 3.28 gives us 28.7. So then now if we divide it by the 4.1, because remember what we're doing now is we've got the area, 28.7 meters squared divided by 4.1 to give us the length that we wanted earlier, we get the answer of 7. So hopefully you can see here just how important the conversions can be and also understanding the foundations, the principles, the maths behind actually making these conversions happen because they make questions like this possible. Alrighty, let's move on to the next question. How much will it cost Sarah to have check tiles in room B? So pause the video now and have a go. Fantastic. So let's go through it now. So we've got check tiles in room B, which is here. So we need to find the area. How do we do that? The length and width, which we've got here. So it literally just looks like multiplying these numbers together. And when you do that, you get your answer of B in this case. So a bit more of a straightforward one here. And lastly, we've got one more. Feel free to pause the video here and have a crack. Okay, so let's run through this question together. So if the width of room B is 26 feet, then how much would it cost to cover half of the floor in wood and half of it in carpet? So we know that the first step in our 3C's is going to be to convert. We've got a value of 26 feet here. It's basically saying this is no longer 8.4, it's 26 feet. So with that in mind, how do we know what unit we want to convert to? What stops us from converting this all to feet, for example? Well, what stops us is the fact that we know that we're going to need to multiply by the cost at some point, and this cost is given to us in per meter squared. So we want to be working with meters wherever possible. So the first things first is to convert this 26 into meters. 26 divided by 3.28 gives us 7.9268. I'm just going to put 7.93 for simplicity's sake. Cool. Now, we know that we're going to get the area, we're going to divide it by 2. So let's find out what half of the area of B is. 7.93 times 2.9 gives us 22.98 as the area. So if we divide that by 2, that gives us area on 2 equals 11.49. So now we have the meter squared that we're going to use to do these multiplications with. First of all, it's going to be with wooden, and then it's going to be carpet. So for wooden, it's going to be 11.49 times 22.4. For carpet, it's going to be 8.5 times 11.49. So if we put this all together and get your calculations, you are going to end up with the answer of C in this case. So hopefully you can see here how we've used those 3 C's. First of all, doing the conversion, then knowing what formulas to use for the length and width, and then actually doing the calculation to get to the answer in this case. Fantastic. Let's move on to another few examples of area and geometry questions. Now, we'll just put a disclaimer out there. This one is on the harder end, but I genuinely think if you can wrap your head around this kind of question, then you're going to be fine for any area and geometry question that comes your way. So feel free to pause the video here and have a crack at this question. Okay, so now that you've had a fair go at this question, let's have a look at how we can go through this one. So the tricky part about this question is basically just the abstract reasoning of what's going on here. So let's just visually depict what's going on here. We've got some paint rollers, which kind of look like this, and you've got a cylinder attached to it. So that cylinder can look like this, right? Now, the question's asking how much area of a wall would a paint master roller cover in 25 complete revolutions? How much area? Now, if we think about it, how much would the paint roller cover in one revolution? It would be the curved surface of the cylinder, which is why they actually give you this formula right here. So let's just pretend like I put a cut down the middle right here. Not on both sides, but just on one. Then we unraveled the cylinder. Then what it would look like is actually exactly like this. If you can imagine rolling a piece of paper into a cylinder and then letting it go, it's just going to look like this. And then so what we have in front of us is actually a situation where this ends up being the circumference of this circle right here, and then this ends up being the length that we're talking about. This is the length of the paint roller, or in this case, the same thing as height. So the length and height here actually mean the same thing, but they're just using terms interchangeably. Number one, to confuse us, or yeah, basically just to confuse us. So we're going to put height here as well. So hopefully you have an idea of what's going on. Now, with one complete revolution, we know that it covers this much ground. And so the question is, how much does it cover in 25? So what we really need to find here is, what is the curved surface of the cylinder? And then multiply that by 25. That's our objective here. Okay, now let's go through the 3C's once more. I can see that my answers here are in meters squared, but my length and diameter are given in centimeters. So I'm probably not going to convert them to begin with, just because I can do that all at the end. It'll make it easier in terms of time efficiency, but I'm just going to really keep that in mind. And if it were me, I would probably just put a big meter squared on whatever working out paper I had, just to keep in check that I know I need to convert. So with that in mind, let's start the conversion. We can get the curved surface of the cylinder through this formula. So we got 2 times pi, which is given to us as 22 on 7, times the radius, which is going to be here 28 divided by 2. So the radius is just half of the diameter of a circle. And then we have the height, which in this case is 63. All the while, I'm keeping in my head that this is a centimeter value and this is a centimeter value. So if we do that into the calculator, then what do we get? I'm just going to pop that in real quick. We end up getting the number 5,544. We know that this is in centimeters squared. And what I want you to get in the habit of is knowing exactly what you've calculated at all times when you've got an output in the calculator. So this is the curved surface area of the cylinder in centimeters squared. It helps to know because we know that we're not at the 25 mark yet. We've only just got 1. Anyways, we're going to convert this into meters squared. We do that by dividing by 100 and then dividing by 100 again, giving us 0.5544. And now if this is 1 and we need to find 25, we multiply by 25, giving us our answer of 13.86 meters squared. So quite a complicated question here, but this is how we go through it. Once you understand conceptually what's going on here with the area covered by the paint roller and the curved area of the cylinder, then this becomes doable. All right, so let's take this understanding into the next question. Feel free to pause the video here and have a go. All right, so let's go through this question together now. So, painting company charges 75 pence per square meter. Immediately, the conversions are screaming out to me. We know that we're going to need to work in meters if we want this to work, not the centimeters that we have here. If the company used a quick coat roller to paint a wall in 80 complete revolutions, how much did it charge for everything? So what we need to find is the curved surface area of the cylinder for 1 revolution. We multiply that by 80, and then that gives us the centimeters squared. Then we convert that into meters squared. And then we're going to multiply it by 0.75 because it's 75 pence per square meter. And then that will give us the number that we're looking for. So let's do exactly that. We're going to pop this into the formula. 2 times pi times the radius, 39 on 2, times the length, which is 45. And this will give us our centimeters squared value. And then we're going to divide that by 100 twice to get our meters squared value. And that's going to be something along the lines of 0.5516. So this is our meters squared for 1 revolution. But we know it took 80 revolutions to complete. So we're going to multiply that by 80. And so this is the total meters squared of the wall. Fantastic. Now we know if it's 75 pence per square meter, then we multiply this by 0.75, giving us our answer of 33.09. So if you've got 33.09, fantastic. That answer is correct. But in this case, the answer is C, because when I made these questions, it rounded on every step of the calculation. So it just rounded to C. The real value here would have been 33.09. So if you got that, fantastic. And we've got one more question to go through, which is this one. So feel free to pause the video here and have a go. All right, so let's go through this question together now. Wall whiz roller was used to paint a wall of height 18.48 in 120 complete revolutions. Assuming that it only made complete revolutions, what's the width of that wall? That's what we're looking for here. So just to kind of visually draw this out, we've got a height, which is 18.48, and we are looking for the width in this case. And the way we find that is by finding the area, dividing by 18.48, which gives us this width. So our understanding of the formula there really does help out. So then we jump into another roadblock, which is what is the area? That's what we need to figure out in order to find this width out. So we know the process already. We've done it a bunch of times before. So let's do it. We find the curved surface area of the cylinder in this case. So that looks like 2 times pi, or 22/7, times 43 divided by 2 times 84. Once again, keeping in mind that these are centimeters, I want to be working in meters. Don't make that mistake of having this centimeter squared value, dividing it by 18.48, and then wondering why we're not getting the number that we want. And in this case, we get the number of 11352 centimeters squared. Here, I'm just going to divide by 100 squared to get myself meters squared. The reason I'm doing that is because the next step really is to just find the width, because we've got the area now, and I want to be dividing a meter squared by a meter value that we have here so that my calculations are easier. So if we do that, then we get 1212, we get 1.1352. Now that's just one revolution, right? If you can imagine, that's just one of these. We need to multiply it by 120 to find the whole area of the wall. And if we do that, 1.1352 times 120 gives us 136.224 meters squared. So that is our area. Once we have the area, we can divide by 18.48 to give us our length, or the width of the wall here, which is 7.37. So this is our answer, and rounded gives us 7.4 meters. Fantastic. So hopefully this has been a good set of questions to really get us thinking, to understand, or almost visualize, conceptualize what the area questions can be like. This is a difficult set of questions you've just done, but if you can understand your way through this, then I think you're basically ready for any area and geometry question that can come your way. So good on you. Now, this was just a set of questions that we've done, and if you want to do more practice to get even better at these questions and you don't already have a question platform, then you can use the code Farhan for 10% off med entry. Otherwise, here are a couple traps that students tend to fall into when it comes to area and geometry questions. Number one is mixing units inside the calculation. Absolute no-go. Number two is not reading the fine print, because clues are often given there. Now, I can't tell you how many marks I've lost because I forgot to print, so please always do. And number three is trusting an answer in a different unit, because that's what your calculator shows you. So let's just say you've got 700 in your calculator, but the real answer should be 7, and you just forgot to do the conversion. Best believe they're going to put a 700 in there just so you can pick it, think you're correct, move on, only to get the question incorrect. So make sure you're on top of units at all time. So here's the do's and don'ts. Do pay attention to the unit the answer needs. Do convert all lengths into the same unit before calculating, or after, if you can keep that in mind. And do remember to multiply or divide something twice if converting area values. For example, meters squared to feet squared. Don't trust options that copy your meter squared answer but slap a kilometer squared on it. It means that we've gone wrong somewhere. Don't plug mixed units into formulas, and don't overcomplicate shapes. Break compound shapes into simple rectangles, triangles, and semicircles instead. So here's your next step. For the next 20 area and geometry questions that you do, I want you to apply the 3C's relentlessly. I want you to convert, choose, and then calculate, and then see how you go when it comes to timing and accuracy.